this nice topic. This learning will definitely help you to approach any problem on process calculation very comfortably. Okay, to start with, this topic is atomic balance and extent of reaction methods for solving material balance problems for chemical engineering. Okay, this is the first lecture in this lecture series. Every fortnight we'll have one such lecture. Let us see about this atomic balance. Of course, we all know this atom cannot be created or destroyed. Of course, there is an exception for this, what is called as nuclear reactions. Nuclear reactions, one atom is turning to another atom. Of course, in most of our chemical engineering calculations, we don't have that kind of reaction. We have only normal chemical reaction. So for which these atoms are conserved. So always there is atom balance is always valid. So whatever the atoms entering should appear in the outlet. Of course, for a steady state process, atom in equal to atom out. So you need not worry about anything about the chemical reaction. Simply by making balance on each and every atom involved in the chemical reaction, you can simply get the calculation done. This is a very straightforward approach. Or of course, it may lead to large number of equations. But given the availability of a computer, you can easily solve these problems comfortably. So for this method, you need not worry about the number of equations available. There is, suppose most of the time the chemical reactions, it's not a single reaction like C plus O2 giving rise to CO2. It may also have like C plus O2 giving rise to CO, or C plus CO giving rise. Or we can have many reactions normally happening. And if you are given with a process having a large number of equations, we cannot use simply solve by the usual molecular balance approach. Instead, you can comfortably solve these problems by using atomic balance approach. We'll explain this concept with two examples. And another nice approach, of course, this approach we normally use for chemical reaction equilibria. Always this equation is directly available in your the standard book on thermodynamics, namely Smith and Vaness. Or is the moles of a component at for any extent of reaction is Ni, that is equal to initial moles plus the the number of moles multiplied by yeah, actually this is a slight mistake. I will correct this. It is not Ni, it is nu I. Nu ij. Okay. What is that? Nu refers to the extent of nu refers to the stoichiometry coefficient of reaction. E or the epsilon is the extent of reaction. This extent of reaction is quite useful for dealing with multiple reactions, as like this atomic balance method. Of course, we can also use this for single chemical reaction also. We'll try to see these two methods. Of course, all of you are comfortable with your usual molecular balance approach, which is a molecule entering, which may getting consumed or getting generated. So you'll be writing this N equal to N minus consumption equal to the generation plus output. That sort of balance you'll be writing. And we used to solve any problem using that approach. Of course, that solution may be coming in 2-3 steps. But sometimes where to start? There is normally the toughest point in approaching these process calculation problems. But these two methods are having a straightforward approach. So this learning will definitely help you. Let us see these two methods with reference to the example of formaldehyde from oxidation of methane. Of course, I am taking this example from this 2021 GATE 2021, which is a 2-mark question. Our chemical engineering GATE questions. This the problem statement: formaldehyde is produced by the oxidation of methane in a reactor. So methane is oxidized to get formaldehyde. Two parallel reactions occur. The first one is methane plus oxygen giving rise to formaldehyde. The second one, methane is also undergoing direct oxidation to give this carbon dioxide and water vapor, the combustion reaction. Actually, we are interested in making this formaldehyde from this methane oxidation. Of course, this reaction is also happening. So let us read the complete problem. So methane and oxygen are fed to the reactor. methane and oxygen are fed to the reactor. The product gases leaving the reactor include methane, oxygen, formaldehyde, carbon dioxide, and water vapor. So there is still methane available in the product, which means there is incomplete reaction. So methane, in addition to methane, we have all these components, namely what is it? Oxygen. Yeah, even oxygen is also not utilized. Oxygen, then formaldehyde, carbon dioxide, and water vapor. So almost all the components are there in the product. Okay, let us. There are some information about the product. 60 moles of methane enter the reactor. To the reactor, we have this 60 mole of feed, methane feed. The molar flow rate of CH4, O2, and CO2 leaving the reactor. So what are all the of course, there are many components in the product leaving. We are given with the information about methane, oxygen, and CO2. Their amounts are given in moles per second. So we are asked to find the molar flow rate of oxygen entering the reactor. So let us first represent this schematically. So we have methane entering at the rate of 60 moles per second. So 60 moles per second of methane enters. And we have this methane leaving in the amount of 26 moles per second, O2, 2 mole, and CO2, 4. So we can write these moles. So in the product, in addition to methane, O2, and CO2, we have the essential product, that is formaldehyde, and also the water vapor because of the reaction. So in the product, we have the information about methane, oxygen, and carbon dioxide. In the feed, we have information about methane. So what is the thing asked? We need to find the flow rate of oxygen entering the reactor. So we need to find how much of O2 enters. So let us represent these in terms of the numbers. There is N1 refers to molar flow rate of methane, N2 that of O2, and as like that for all of these components. I am associating with this what is it? The symbol N5 refers to formaldehyde, which is the product of this reaction. Okay, now let us see this atomic balance. So what are all the atoms entering? Okay, in these reactions we can see, of course, it is a oxidation with pure O2. So we have carbon, hydrogen, and O2. We have C, H, and O. These are all the atoms involved in the reaction. So we can write definitely 3 balances. So first, let us write balance on carbon. So how much of carbon enters, that is equal to carbon in the product. So how much carbon enters? We have this methane entering at the rate of 60 moles per second. So for 1 methane, we have 1 carbon. That is, for 1 molecule of 1 mole of methane, we have 1 atom of, what is it, this C. Say in 1 CH4, we have 1 C. That's it simply. So 60 moles of methane is entering. So in 60 mole, we have 60 into 1 atoms of C is entering. And where it is leaving as methane as such, and it is leaving in this formaldehyde and in CO2. So we know this methane amount in the product, so that is 26 mole. So 26, and 1 mole is having 1 C, and this, what is it? This CO2. We know the flow rate of CO2, which is 4 mole per second. So 1 mole is having 1 C. So that's why 4 into 1. And this another component, there is the formaldehyde. We have this molar flow rate, which is N5. N5. This is molecular formula is HCHO. 1 HCHO is having only 1 C. So that's why 1. So otherwise, this is now saying in terms of how much of atoms entering and how much of atoms leaving. So here we can directly now get the value of N5. What is it? This formaldehyde amount is now directly coming. Now here I didn't write anything about the reaction. No, though there is a what is a reaction? We have these 2 reactions. I didn't say anything about the reaction. Simply I am writing these product components, and for every product component I have this this symbol molar flow rates, and whatever the data available I have written, and I could now. So I could now simply have this balance, atomic balance on C first we have done like that. Okay, from this we get the molar flow rate of N5, which is formaldehyde. So formaldehyde amount is now known. And we will also write the balance, other two balances, one on O and another on H as well. So balance on O, how much of O entering? There is N1, N2. There is N2 is a flow rate of O2. In one N2, we have two atomic oxygen. So there is N2 into 2, there is atomic oxygen entering. And where are all this O2 leaving? O leaving. O is in N4. One N4 is having, there is 2O. And here, no, this is having 1O. There is N5 into 1, N4 into 2, N5 into 1. N4 is already given us the value of 2. So 2 into 1, 2 into 2, because this is having 2O and this is having 1O. And this N6 into 2. N6 is already 4. So 4 into 2, that is the O in CO2. And this N7, which is H2O. H2O is having 1O. So N7 into 1. So now, of course, we have many unknowns here, N2, N5, N7. And already we have this value of N5 calculated from this balance on C. And using that data, now we have, there is N5 is available. Substituting that, we have this N2 and N7 available in, right. And using, just I'm using this. So because of that, this N5, this equation is now, N2 is unknown, N5 is available, N7, N2 and N7. Otherwise, we have the two unknowns, namely N2 and N7. What is this N2 and N7? N2 refers to O2 and N7 refers to that of water in the outlet. Okay, connecting that, we have this atomic balance on O. Now, let us see the other equation coming from this balance on H. So, how much of H enters? H is entering only in the methane. So, 61 methane is having 4 H atoms. So, 60 moles is entering. So, 60 into 4, that is a H in the inlet. As like that, we can also write the H in the outlet. This 26 into 4 and this N5 into 2 and N7 into 2. So N5 into 2, N7 into 2 and 26 into 4. Okay. So now again, these unknowns are N5 and N7. N5 already we have from carbon balance. So substituting that, now directly we are getting this N7. So what is this N7? N7 is H2O, but what is needed is O2. So N7 is now available. Substituting this N7 in the balance on O, we will be getting directly the N2. Flow rate of oxygen in the inlet. That is a needed result. Of course, the calculation is appearing to be lengthy, but it is very straightforward. No? How many equations to be written? Only that it is based on the number of atoms available here. So we have carbon, hydrogen, and oxygen. These are the 3 atoms involved. So you'll be having these 3 balances. And if you write the balances, definitely the results are automatically coming. Okay, we'll also try to attempt this problem using the extent of reaction method. So for that, the formula, of course, is Ni refers to the moles of component I for any extent of reaction. The extent means progress, no? Any progress of reaction. Ni initial, the moles of the component I is equal to the initial moles plus this sigma J for the jth reaction into or is a summation of this nu ij Ej. So always we can comfortably write for this here. Of course, we need to write the equations. Chemical reactions are needed. Then only you can write this amounts. Okay. So now let us try to understand this. So the products already we know this CH4O2, CHO, HCHO, CO2, everything is available. And so we are going to write this thing now using this formula. So what is there? Methane in the product. We already know this amount, which is 26 mole per second. but this equation we can write based on this. So what is this? This of course the N3, N4, N5, 7. Simply we are using the same symbol already we have used here. Okay. Now, how to write this? So this, what is this formula says? This now I refers to methane. So moles of methane in the product, there is N3, that is equal to initial moles. Initially the feed is having 60 mole, that will be there, the initial moles. Why do we have negative? Because feed is this stoichiometry coefficient for the for the reactants are negative. For the product it is positive. Or is nu is positive for the products and nu is negative for the reactants. So that's why minus E1. Why it is 1? Because only stoichiometry coefficient is 1 for CH4, 1 for O2, like that. No? Whereas for CH4, for the first reaction, it is stoichiometry coefficient is minus 1. And for the second reaction also, it is minus 1. Whereas this is, I write this equation comfortably. For then since there are two reactions, I can write this Ni equal to Ni naught plus nu I of the first reaction, extent of first reaction, plus nu I of second reaction into extent of second reaction. That is the meaning of this summation. No? That is the meaning of this summation. Okay. Now, what is the Ni naught is 60 for the methane, and nu I is nu I of the first reaction is minus 1. For the second reaction also it is minus 1. That's why this minus 1, minus 1, minus 1. And simply E1 and E2, the extent of reaction that we are going to solve from the available data, and using that we'll be arriving at the necessary calculation of N2. Okay. Now, for methane I said how to do. Like that we'll also write for O2. So O2 is also taking part in the two reactions. So O2 initial O2 is N2. There is Ni naught is N2, and O2 is having the stoichiometric coefficient of minus 1 in the first reaction, minus 2 in the second reaction. Let's say minus of E1 and minus 2 of E2. With the value of that is already given in the problem statement. And as like that for formaldehyde is appearing in the first reaction alone, and it is having a stoichiometric coefficient of 1, and there is no formaldehyde in the product, in the feed. There is Ni naught is 0. So that's why we have this N5 is simply E1. E1, or it is to be called as epsilon 1. Simply I'll take it as E1. And this N6, what is this? CO2. CO2 is appearing in the second reaction alone, appearing as the product, and its stoichiometric coefficient is 1. That's why N6 is directly E2. And N7, water is appearing in both the reactions. For the first reaction, the stoichiometric coefficient is 1. For the second reaction, it is 2. That's why E1 plus 2 E2. That is simply this. Initially, there is no water, and this is simply 1 and E1 plus 2 into E2. That's why this H2O in the product is N7, which is equal to this amount. So now already some values are available. Say for example, this CO2 in the product is already given as 4 mole per second. So since this CO2 is available, which is directly equal to epsilon 2, there is E2. E2 is now directly known, 4. And since E2 is available, we can also now solve for E1 because already this data is available. Or using this equation also you can solve. So I can solve for this E1 using the data of CH4 in the product, which is coming as 30 mole per second. But what is needed is N2. What is N2? How to get N2? You can directly solve this equation now. E1 and E2 are available. You can directly get the value of N2. So from the equation of using 1 and 2 in above, what is that? 1 and 2 are from CH4 and from the data of CO2 and from the data of O2 in the product. There is this equation which is N4 minus epsilon 1 minus 2 epsilon 2 equal to 2. Here we have to substitute E1 and E2, and directly we are getting the N2, which is the 40 moles per second. Okay, let us also see the usual molecular balance approach. Of course, I didn't give this elaborate steps here, but let us also understand how we used to do in the usual way. So the reactions are given, and it is already given that 4 mole of CO2. Or we know these amounts of certain components in the product. Okay, from the data, 4 moles of CO2 in the product indicates. Or we know the amount of CO2 in the product. 4 mole of CO2 will come from 4 mole of CH4. Okay, 4 mole of CO2 in the product indicates 4 mole of CHO in the O getting reacted as per reaction 2. That is a meaning. And we know how much of CH4 is reacting as per reaction 2 based on the data of CO2 in the product. Now, for this, how much of O2 is utilized? That also we can get to know, because at last we need to get how much of O2 entry. So for this reaction, so based on the amount of CO2 in the product, which is 4 mole, we know this 4 mole of CH4 is utilized in this reaction. And additionally, we also get to know that 8 mole of O2 is utilized for this reaction. Okay, that is the information. Next, how much of CH4 is reacting as per reaction 1? That is simply from this balance on this CH4 in feed minus CH4 in product. So these data are available. Methane in the feed and methane in the product are available, and methane used as per reaction 2 is also now just be obtained. So the balance is going to be utilized as per reaction 1. Otherwise, the methane in feed minus methane getting consumed as per reaction 1 and minus consumed as per reaction 2, that is equal to methane in the product. So that balance only we have written. So methane in feed is known, methane in product is also given, and methane in the reaction 2, that also we just got to know that. So methane undergoing reaction as per the first one, which is also we could calculate, which is 30 mole. Now, how much of O2 got utilized for the reactions? Already we know the O2 for the second reaction. So O2 for the second reaction is already available, which is 8 mole. And O2 for the first reaction, how much? Because we know how much of methane is getting reacted as per reaction 1, which is 30 mole. So 1 mole is taking 1 mole. So 30 mole of O2 will be utilized here. So O2, how much is it is entering? It is nothing but the O2 utilized in the reactions, because there is no O2. Yeah, what is there in the product as well. So using that data also we have did some calculation, right? No, or is O2 entered equal to O2 used in reactions 1 and 2 plus that in the product. That is what is the O2 entering. So O2 getting utilized as per second reaction were first evaluated. Then we calculated how much of CH4 is reacting as per reaction 1. Using that, we get to know how much of O2 is utilized in that reaction. Then this is again simply the molar balance on O2. O2 entering equal to O2 used in the reactions plus O2 there in the product. That is the O2 entering. Okay. Of course, here where to start and how to arrive at, these are all not clearly available. Whereas this method, the two methods, whatever we have seen, this atomic balance, very straightforward. No, so you simply write this, draw this schematic and write this moles and write the balances, whatever the balances possible. So the balances possible are C, or is balance on C, H, and O. Only these 3 atoms are available. So you can write that balances, and automatically the solution is coming. As like that, even the extent of reaction method also, simply write these moles in terms of extent, and you can easily solve based on the available data. So there is a solution procedure is straightforward, whereas the usual approach, sometimes you don't get this point. No? There is if you could not arrive understand this point, you cannot start. There is the starting is not so easier in this usual approach. Of course, the solution will come in 3-4 lines. But these things, that the 2 other methods, namely atomic balance and extent of reaction methods, though the steps are lengthy, the solution is guaranteed. That is, the answer is guaranteed. Okay. So in that way, you can definitely consider these 2 methods. And I will explain these methods usage for little more complicated equations. So let us try to understand this problem. This is about again the formaldehyde. Of course, earlier it was using methane, now it is from methanol. Somehow we could have the same kind of problem. Here it is involving many reactions. 1, 2, 3, 4, 5 reactions are involved. We are going to see by both this atomic balance and extent of reaction method. Additionally, we are also going to calculate conversion and yield. So this problem I have taken from this Bhatt Vora. This problem number is 4.11. Of course, exercise problem. The previous one I have taken it from our gate question, and this is from Bhatt Vora. Of course, the book Felder is nicely using these approaches for solving. Always it is giving quite large number of examples. Of course, the example exercise what I am going to give is from Himmelblau. Okay, we'll see that. Before that, let us try to see this problem. First 3-4 lines you can read through yourself also. In the manufacture of formaldehyde, methanol is fed to a certain steam heated horizontal cylindrical vaporizer. Not worry about this thing. Designed to produce vapors at 85 degrees Celsius and 1.25 bar. Of course, this data also may be useful, but not so needed. Okay, anyways, these are all the about the preparation of this thing. Okay, the feed is at a temperature of 85 degrees Celsius and 1.25 bar cage pressure, and air is introduced with the help of a blower, and it is compressed and heated to 70 degrees Celsius and mixed in a controlled ratio with methanol vapors. Not to worry about these things. Okay, the mixture contains approximately, that is very important. So always we have a feed mixture which is methanol and air. So we have methanol and air. Air is needed because oxygen is there, and the oxygen of this air is reacting with methanol. Okay. So air is okay. Let us further complete this reading. The mixture contains approximately 1 volume of air for each volume of methanol vapors. So that is a very important thing. Otherwise, we are now getting the feed composition, which is 1 volume of air for each volume of methanol vapor. Otherwise, this methanol is to air is 1:1. That is a information. Only this information is needed. The previous things are just about the how that is prepared. Okay. In the reactor filled with silver catalyst, the mixture is passed. Okay, this mixture of what is it? Methanol and air in the ratio 1:1. Of course, it is given a volume, 1 volume for 1 volume of air for each volume of methanol. But we also know we can assume this ideal gases for this mixture for this gaseous component. For ideal gas, is volume is proportional to moles. So always one. How do we say that? PV equal to nRT. So V is proportional to N. So always if you say in terms of 1:1, V is to V, volume is to V, volume, we can also take it as moles is to moles. Otherwise, we have 50-50 methanol, or is 50% methanol and 50% air. There is a in terms of molar composition as well. So there is a feed, and let us read this. The hot gases from the reactor, of course, it is sent going to a reactor. The hot gases from the reactor, of course, we are getting a gaseous components from the reactor, which are cooled and scrubbed in an absorber. So there is a process which is first thing is cooling and then scrubbed in an absorber. The gases free from methanol and formaldehyde. So from the gases leaving this absorber, which has what is it? Methanol, formaldehyde as also. In addition, we have these components, namely carbon dioxide, carbon monoxide, methane, oxygen, hydrogen, nitrogen. So of course, nitrogen is not there in the reaction, but nitrogen is also coming because of nitrogen in the air. Okay, these components are coming. So always we have a specification of the product. Product specification is available, and feed composition is also available. Not the entire composition components of the product. We have limited information. Always we have excluding methanol, formaldehyde. These components are available in the product gases. In addition, there is also water vapor. That water vapor is information is also not there in the thing. Of course, water is getting scrubbed in the absorber. That's why there is no information about the water in the product gases, but definitely water is also involved in the reactions. So what is needed? We need to get the conversion of methanol. So how much of methanol is getting converted? How to say, no? How much of methanol entering minus how much of methanol leaving? Methanol leaving there is also methanol leaving. That information is not available here. Of course, they say like this is the gases free from methanol and formaldehyde are having this composition. That means these components also appearing in the product, but we don't know the amount or composition. Okay, we have this composition of these gases, namely CO2, CO, CH4, O2, H2, N2. These are all like non-condensable gases. So whereas these gases like methanol and formaldehyde, they can be easily condensed. That's why these are all not included. Otherwise, this is kind of a non-condensable gas composition is available. So now we need to find the conversion of methanol. That is the first part. Second thing is the yield of formaldehyde based on the amount of methanol converted. So how much of methanol is, how much of formaldehyde is getting produced per mole of methanol reacted? That is the second part, second question. So first now let us solve by atomic balance method, which is the feed is methanol is to air, 1:1, there is a combustion. And we have, let us take the basis. No, normally the basis is to be chosen wherever you have a complete information, nearly complete information. We have this the product gases. No? What is the non-condensable product gas? This combustion is available, which is this we take it as E. E refers to the exhaust. Okay, which is the exit from the reactor, which is the gaseous components. In addition, we also have this methanol and formaldehyde. So what are all the thing available? M and A, which is available in the ratio of 1:1. That information is available. Methanol is to air is 1:1. Of course, air composition also available, which is 21% O2 and 79% N2. Or is this O2 and N2 of this air also proportion we know. And we have this the composition of the E, which is CO2, CO, CH4, O2, H2, N2. Just I have taken this data. And also you check that this thing is totaling to 100. Then only the composition is completely given. Okay, that is also coming to 100. Let us not worry much. And we also know there is a formation of water, and water would have been removed in the scrubber itself. That's why that data is not there available. But from the reaction, water is also there. So let us take that as the always the flow of, since these are all in mole, this N1 refers to moles of water, and N2 refers to moles of methanol, and N3 refers to moles of formaldehyde. So otherwise, we are going to see the how much of, otherwise we should know this N2, N3, and M, as well as A and N1. So these 5 unknowns are available. In what way? This one, two, three unknowns. And if you have this another unknown, namely M, the other is M. A is automatic because M and A are in 1:1. So now let us start with the simplest data available. The nitrogen balance is the easiest one because nitrogen entering is nitrogen leaving. Nitrogen in the product we have. So simply from that we can get to know the nitrogen in the feed. There is a nitrogen of the air, and from that we can easily get the methanol in the feed. So this is a easy starting point. So this also like now we are going to make the atomic balance. Of course, you can also write molecular balance because N2 is not at all getting reacted. So you can write atomic balance or molecular balance. So molecular balance on nitrogen, which is equal to nitrogen is entering in, nitrogen at the inlet is 0.79 into A. There is a N2 in the inlet, and N2 in the outlet is 74.2 mole. If you want to write in terms of atomic balance or balance on N, it will be like 0.79 into 2 into A. No, or is 1A will be having 0.79 into 2 of N. That is 0.79 into 2 into N. And here also you should take it as 74.2 into 2. Of course, 2 will get cancelled. So it is immaterial whether you write balance on N2 or balance on N. Doesn't matter. Okay, now from this balance, we have this amount of A. And once the A is available, M is also known. So now A and M are available. Okay, that is the first balance we have made. Now, what are the other balances possible? Let us check that. We have this CHO. So CHO, we can make balances on carbon, hydrogen, and oxygen. So carbon, hydrogen, oxygen. So let us make the balance on carbon. So how much of carbon entering? So we know this methanol entering from this just calculation. So for one methanol, we have 1C. No, sorry, one C. So that's why this 93.92 into 1. And where this C is leaving in this CO2 is 4.8, and this is 0.2 directly, and this is 0.3 because one methane is having only one carbon. So 0.3 is having 0.3 carbon, and these are all not having. And here N2 into 1 and N3 into 1. Okay, N2 into 1 and N3 into 1. So now balance on C is available, from which we have a equation. As like that, balance on H. Balance on H. Here for in the M, we have 4 H entering. The M is 93.92. 93.92 into 4 H is entering. So this is a H at the inlet, and H where it is leaving, H is leaving in N1. N1 into 2. There is a H in the H here, and here H is 0.3 into 4 and 20.2 into 2, and here this is N2 into 4 and N4 into 2. We check that N4 into 2, N2 into 4. Okay, these are all written. So now again we have a equation which is already we have this N2, N3. Now also we are having N2, N3 and N1. Maybe we can make use of these equations and still reduce this one. But before before that, let us also write the balance for O, atomic balance on O. So how much of O entering? Already we know the O of this air, and O here is also known. So O in the inlet is known, and O in the outlet. This is O here, and there is O here. And for as like the previous thing, also write the balance on O. We have these equations. Now, somehow we have to reduce equations and solve for. Okay, we have written the balances. Balance on N is written, balance on O is written, balance on H, balance on C. So these are all the available balances, possible balances. So using these balances, of course, we could solve now N1. What is that? N1 refers to the water here, and N2 and N3 also possible. Let us check that. Yeah, so this and all you can do it yourself, and I could get the value of N2 and N3. So otherwise, N2 and N3 are nothing but this methanol in the exit and methanol in the formaldehyde in the product. So formaldehyde, methanol, everything is available. So what is needed is percentage conversion of methanol. So methanol in the feed is already known, and methanol in the product also we just got. So what is the conversion definition? Conversion is simply what is there in the feed minus what is there in the product. Otherwise, how much of methanol is getting converted divided by how much of methanol is entering. So from that we can get this conversion is 53.08%. Next, the yield. Yield is based on the amount of methanol converted. Service yield definition is how much of formaldehyde produced divided by how much of methanol converted. So methanol in the feed minus methanol in the product. There is a this is the amount of methanol converted. So this is the amount of HCHO produced. So using that we get the yield calculated to be 89.4%. Otherwise, to summarize, whenever you see this kind of lengthy equations, better to go for this atomic balance method. You can also write this extent of reaction method. Let me quickly tell you that. Yeah, here we have 5 equations. No, how many equations? What are the equations? 1, 2, 3, 4, 5 equations. So for 5 equations, okay. Of course, we know the product. This E, the value of there is a components of the E is available. For here again, what are the components? For the CO2 is appearing in reaction 4 alone. So there is CO2, which is actually given as 4.8 mole, which is written as simply the formula. No, already what is the formula of this formula? Simply implement for the every components. Maybe I'll copy it, paste it here. Fine. That formula is implemented. Of course, CO2 is there only in the fourth reaction, which is in the product. So it is simply E4, and CO is there in the second reaction, which is also having not only in second reaction, CO is also there in the fourth reaction. It is here, it is having a stoichiometric coefficient of 1. This is having -1. So otherwise, we have this E2 minus E4. Of course, these components are not there in the feed. That's why there is no the plus term available. Okay, there is no Ni naught for these components. Okay. As like this, also write for this methane. Methane is there in where all the methane. Okay, this methane is here. Only methane is there in the reaction 5 alone. Yeah, it is directly E5 is 0.3. Otherwise, these values are now directly coming. What is needed is in these problems, we need to first solve for this extent of reactions. E1, E2, E3, E4, E5 are to be solved so as to get this N1, N2, N3, N4. So whatever the unknowns. So by using the available information, we can solve for some of the reactions extent. Then the other things are automatically coming. Otherwise, to summarize, these two methods, though appearing to be lengthy, they are very convenient. In what way? Otherwise, a solution is guaranteed. Whereas the usual molecular balance, we have to start properly. Otherwise, many times we'll be keep on trying to start. Whereas this starting here, there is no such starting trouble. Otherwise, to simply say like, okay, maybe yeah, just we have done with these two examples. Maybe you can note down this problem, and I will also give you the solution. I will give you the answer key so that you can also verify yourself. Simply, always this problem is taken from this Himmelblau. What is it? Supplementary. Sorry, I don't know this. Self-assessment test. Okay, self-assessment test in the third chapter, 3.4. The question number is 13. Okay, you can simply take a snapshot of this question and try yourself. And I will give you the answer. What is the answer? This is simply ratio of H to C in the fuel. So the answer is H to C. H to C is simply 0.811. Here the reactions are very simple reactions. We don't know the hydrocarbon. So what are the reactions possible? The carbon will be undergoing reaction, and it may have this reaction like C plus O2 giving rise to CO2, or also C plus half O2 giving rise to CO. In addition, H will also be there, but that analysis is not there. This Orsat analysis will give you the dry gas analysis. So there is also water vapor also getting produced. So the water vapor content is not available, but this also getting produced. So you can try this. You try yourself. The solution of this will be posted by tomorrow. Okay, now it's open. I'm welcoming you to ask any question. If people can unmute themselves, and anybody want to ask question, I'm available for another about 15 minutes. Yeah, maybe in this time I will also say about this MSubbu academic courses. Of course, there is also a YouTube video I just recently put up that, which is about what are all the course features. Otherwise, you can simply go through this YouTube channel, my YouTube channel, namely. Otherwise, my YouTube channel is quite easily accessible. Simply you type this youtube.com and followed by slash this art handle. No, after that simply MSubbu Academy. You can directly reach to my YouTube channel. Here and this lot of contents on thermodynamics is available, and recently I'm also putting videos on chemical reaction engineering and also the other subjects, and some typical videos for each and every subject. Of course, these are all coming because of I'm conducting this GATE classes also. Of course, now as of now I am conducting with a limited group of students. The full-fledged class will be happening in the months of this October and November. In the month of October, November, December, I am planning kind of a crash course. Before then also you can access these like recorded contents. Otherwise you need not wait. Now as of now, these recordings of thermodynamics and namely process calculation and fluid mechanics are ready. In another about 2 months, 2-3 months, all the contents will be ready. and we'll be having a full-fledged gate refresher class, or what is called as a crash course. That will be in the months of November, December. In these 2 months, you will be given with at least every day 1 hour of lecture, and we'll be having the weekly about 4 or 5 hours of discussion. That's the kind of thing we are planning. Okay, the full details will be available soon. Okay, I said about this, the typical course features, the typical course content, how it is looking like. I can simply go through this playlist, making best use of MSubbu academic courses. Here in that,
This is a short instructional video on how to utilize the tags present in MSubbu Academy. So when
this kind of videos are now available for you to go through, and how to what is the typical course content.
MSubbu Academy website rundown. Completing.
Yeah, you are welcome to go through this video to understand a typical course. Of course, some of you might have already purchased the courses and you know the features.
Enrollment duration.
But still, you can also again go through so that you can make best use of my this course contents. And these contents are dynamically updated every month. Also, you'll see a lot of updates. In another about 3-4 months, you'll be having good amount of material.
Attendance.
And as of now, the contents are we have the solution for right from 1988 to 2022 available currently. 2023 will also be available in another month's time. Always about 35 years of question collection we have. Not only the question collection, we have the answers and the detailed solution as well. Okay, you are welcome to go through them. And I ask every this user of MSubbu Academy to go through these contents regularly. Then only you'll get full benefit out of this course. Okay, now I'm open for your questions. Let us look for any question. Okay, not much question on the topic. Any of you have any such question on this topic? Maybe I will again open that contents. That is very simple. Equation is also not great, no? What is it? This equation we used to do in our chemical reaction equilibrium of this Smith and Vaness, no? Or what is it? The last chapter of Smith and Vaness, thermodynamics. That equation we can definitely use for our material balance calculations. Not only in material balance, this will also be used in energy balance as well. The energy balance, we also need this material calculator first. Then only we can do the write the energy balance.
Good evening, Subbu sir. Balaji.
Yes, sir.
Sir, nice session, sir. Very interesting.
Thank you, sir. Thanks for following, sir.
Sir, I have one doubt, sir.
Sir.
Sir, can we use this atomic balance for every situation, sir?
Yeah. We need not worry about the reactions available. Simply, we should know. Of course, every atom data should be available, at least in whatever the molecular form. If you have these components, it's possible, sir. It should be possible. Maybe with any specific example, if you have, I can tell you. I tried this. I'm using this extent of reaction and atomic balance. So whenever I see any process calculation problem, I try to use these two methods. These are all. Sometimes these equations are coming lengthy, but okay, solvable. And nowadays we need not worry about this solution. No? Once you form the equations, implement it in this tool like Excel, and you can get the solution. Like earlier we were worrying about this solving. Now the solution is automatic.
Okay.
Yes, sir. Thanks, sir.
For examination purpose, can we solve this atomic balance approach, sir? For
yes, sir. Yes, sir. Nice, very simple approach.
We are having a lot of algebraic equations. It takes time.
But in the usual molecular balance approach, sometimes the starting, where to start. Sometimes that people cannot easily guess that. If you can guess that, okay, maybe the solution is in 3-4 lines. Also, you can get. But here the solution may be lengthy, but definitely I will recommend for this multiple reactions. See, for multiple reactions, we cannot progress in the proper order. Whereas here, where is it? No, only this balance are how many balances? This balance on C, balance on H, balance on O. Only these 3 balances. Maybe if it is any other component like N is involved, so only 3-4 balances. So straightforward. How many balances is very straightforward. So definitely I would even Felder also recommends, I simply follow from Felder only. So Felder recommends to use these methods for complicated reactions or many reactions, whenever you see many reactions.
Oh, thank you, sir. Thank you.
Nice, sir. Thanks.
So
Sir.
can we use this for physical processes, sir? Chemical process alone can be applied, or physical process can be applied?
Physical process, I don't know, because here physical process, there won't be any change of atom, right? Or
Yes.
the molecule, the component won't undergo any change, right?
Yes.
So in that case, what is the need of that? I don't know. So otherwise, this for the reactions definitely needed. For physical process, maybe the composition change or anything is there, like a fertilizer formulation problem. So in that case, there is no such reaction as such. The feed, two different components will be mixed and to get the product. In that case also we can use. Of course, I have used this atomic balance method for even this fertilizer formulation also. I had such solution also available. Yeah, otherwise we can also use not only for chemical reaction based on these components available. Otherwise, whatever the feed entering, whatever the C entering will be there in the C the product.
One widely used problem is acid mixing problem, sir.
Yeah. In the acid mixing problem, I have used this atomic balance method.
Okay.
Yeah, I have that such a solution also.
Yes,
that such problem is there in this Bhatt Vora now. Used to Bhatt Vora
yes,
have that problem. Yeah, right. I also tried this method also. It's also coming very straightforward. Nice.
Oh, okay. Okay, sir. Thank you, sir. Thank you.
Thanks, sir.
Thanks for the opportunity, sir.
Yeah, I'm blessed to get you, sir. In this session.
Thank you, sir.
I'm waiting for some more time. And if any of you have any general doubt, no, on how to use this site, in what way this site will be better. Yeah, many people are asking about getting the print book. The reason for not printing the books, at least for this time, is just to encourage to use this my MSubbu Academy course contents. Of course, the course features are very nice. That's why the features are coming very nicely in this online form. That's why even I don't encourage using the print books. Instead, this website content, of course, currently also people are using. Yeah, maybe this process calculation directly also. Yeah, in this thing, I have also a lot of features, like you can also, anyone want to check based on the year order. So people can directly go to that question. And if any of you mark any specific points to that question, also you can mark. And you can go through these notes. And there are also nice features like this tags. So these tags will help you to go get additional materials relevant to that. And not only that, you can also add any, suppose you want to refer this page later, you can also bookmark this page. So these bookmarks are saved in your this profile. And you can also add any notes also. Say, for example, I am seeing some page and I want to add some, say, for example, here, of course, in somewhere I am also giving this handwritten contents. So suppose I want to add my own notes to this page. So you can simply type something. And these notes will be available with reference to that page. Suppose I'm, you can get back these notes also from your profile. And yeah, you can go to these notes. So there, what are the notes you added are available. And it is also chronologically added. And in addition, you also, whatever the bookmarked pages, that also you can directly go through, jump into that. Service as like a normal print book. And we also have more features than the print book. We also put up a lot of videos. And you can take up this self-assessment quizzes any number of times. Of course, these questions are coming from a question bank. So definitely, each and every attempt, definitely, at least for 4 or 5 attempts, you'll be getting some unique questions. I can guarantee that. And we are also adding questions periodically. And you can also assess, you can also go to a specific topic of questions. That is for crystallization, what are the problems available? So these are all based on the tags, no? Or how problems on recycle. And again, the size of the tags give an idea about how often that topic is asked. So for example, the recycle problems are quite common. That's why this recycle is, and also excess air. excess here. I could see these kind of problems, these many problems. And in addition to the gate question problems, we are also adding problems from the nice books, namely for the subject process calculation. I'm adding questions from, I was not the direct questions, slightly adapted, Felder and Bhatt Vora, this Himmelblau, or any other recent books also I'm adding. So definitely this materials will be very good for your usual semester preparation and also for your directly for your gate preparation. And in addition, in the recent time, we are also having this gate coaching classes, and that recordings are now being available in the form of sellable material. So people, you are also welcome to go buy that material if you are interested. And they are about 10-15 hours of classes for about some 1,000 to 2,000 rupees only. And we will be having a full-fledged discussion, kind of a crash course in the months of November and December. In the 2 months, rigorous classes will be happening. So before that itself, if you can go through these materials of these recorded lectures, or at least in these courses, you can take up that 2 months crash course to completely revise and get yourself prepared for the coming GATE 2024. Okay, how much time left? Maybe another about a minute time is left. If anyone is having any question, rest also you are welcome to mail me through this what is it, mail ID? That is learn@msubbu.academy. Learn, LEARN, learn@msubbu.academy. Or also you can reach us through the WhatsApp number. Details are available in the course homepage itself. Yeah. Okay, let us not wait any further. We are going to end the session, and thanks for your presence before ending. Thank you everyone for your valuable participation. See you in the next session. The next session will be in the third week of third week of July. Mostly on the evening and mostly on the weekend. So normally at least on Saturday or Sunday we'll have. I will intimate you properly. Okay, thank you. I'm going to end the session. Thank you.